Hello guys, good morning. Welcome to the session today. Hope you all can hear me. Can you guys confirm once?
Yes, we are able to hear.
Okay, great. So let us start the session. If you remember guys, yesterday we have seen that a BigQuery, what is BigQuery and how to work with the BigQuery, all of those things that we have learned in yesterday's session. And today we are going to start with one more service, that is DataProc, which is a very important service to work with the Spark and Hadoop system. So let us try to understand what is DataProc. Okay. So DataProc is one of the managed service. It is one of the managed service. That means we need to here. It is a cluster based tool to we need to manage the cluster here. Okay, it is a cluster based tool and we need to manage the cluster here. Cluster based tool or cluster based service. Okay, so if you wanted to work with the data proc, we need to maintain the cluster. So what is actually the data proc? If you ask me, the main purpose of the data proc is to run the Spark and Hadoop jobs. Okay, the main purpose of the data proc in life is to run the Spark and Hadoop jobs. Okay, so why they have introduced the data proc is to run the Spark and Hadoop jobs only, guys. So if you wanted to run the Spark and Hadoop jobs, so in Google Cloud Platform, we have a data proc. Okay, the main purpose of the data proc in life is to run the Spark and Hadoop jobs. So if you wanted to run the Spark jobs, or if you wanted to run the Hadoop jobs, we can directly go to the data proc and create the cluster in the data proc, and then we can run the Spark and Hadoop jobs. So that is the main agenda of the data proc, guys. Okay, so this is the definition. That's it. When it comes to the data proc definition, this is what it is. Okay, so let us try to understand what is Spark and let us try to understand what is Hadoop. Sir, Spark and Hadoop both are the frameworks, programming frameworks, if you wanted to work with the big data. Okay, Spark and Hadoop. If you wanted to work with the big data processing, sir, I wanted to create a data processing pipelines. Sir, I wanted to create a data processing pipelines, or I wanted to create a migration pipelines, or big data pipelines. So if you wanted to create a data processing pipelines or a big data pipelines, so Spark and Hadoop are the one of the major programming models or the programming frameworks which supports this data processing pipelines and which are very fast. Okay, so if you wanted to work with the data processing pipelines, sir, I wanted to create a big data pipelines. Spark and Hadoop are the programming framework. Programming frameworks. So these are very faster. And if you wanted to do the any kind of a data processing or a big data creations, going to the Spark and Hadoop will give you the very good understanding, and you can able to easily create the big data pipelines. Okay. So that is how the Spark and Hadoop. So if you still wanted to know it, let me try to tell you guys. So what is Spark and what is Hadoop? Let us try to understand in a bit. Okay, before that, let us go to the Hadoop. Let me try to explain what is Hadoop and then I'll try to explain what is Spark. Sir, Hadoop. Sir, Hadoop is like to work with the big data pipelines. Okay. So to work with the big data pipelines, we can use the Hadoop. So Hadoop has three main components. It has three main components. One is one is HDFS, Hadoop Distributed File System. Second one is MapReduce. Third one is YARN, Cluster Manager, YARN. So these are the three main components that the Hadoop is having, sir. So HDFS. So HDFS is one of the storage layer. So HDFS is a Hadoop distributed file system where you can able to store any amount of data. As a data engineer, we have two challenges, guys. So if you go 10 years before, data engineers are facing a two main challenges. The 10 years before, if you look at it, they are facing a problem with the two things. One is storing the data. The second one is processing the data. Okay, so the very first one is storing the data, the second one is processing the data. Okay, so that's where when the data engineers are facing a lot of problems with the storage and processing, so that's where the Hadoop was introduced. Hadoop come up with the three components, that is HDFS, MapReduce, and YARN. HDFS solving the storage problem because HDFS is one of the storage layer. So what it will do is that if you wanted to store any amount of data, HDFS will be able to store it. And it is going to be splitting the data and distributing it to the multiple machines in the cluster so that it can able to store any amount of data. So that is what is the storage layer, sir. So HDFS is one of the storage layer where the name itself it is saying Hadoop distributed file system. It works in a distributed manner. So if you wanted to store any amount of data, it is going to be first splitting the data and distributing it to the multiple machines. Okay, so that is what one of the first component that the Hadoop has introduced is HDFS. First, fixing the storage problem, and the next one, so the next challenge is processing. Okay, so MapReduce is to process the big data. So whatever the data that we are storing, we need to process it. So that is where the data, that is where we are going to get some kind of insights. Those insights are very useful for the business. So that is the reason whatever the data that we are storing, we need to process it. Sir, if we wanted to process that much amount of a data, we need to have a very, very good framework which can be works with a very large amount of a data. So such kind of a tool is a map reducer. Map reduce is a one of the processing layer or a engine processing framework you can think of. MapReduce is a one of the processing framework where it can able to do the data processing for very large amounts of the data. But the problem with the MapReduce is that it is a processing layer, but we need to do the data processing in the Java. Okay, we need to write the pipelines in the Java only. Okay, it doesn't support any other client libraries, and it is a disk-oriented manner. It stores the data in the disk only, guys. When you're dealing with the disk, the data storage or data processing is very slow. So, but MapReduce deals with the disk oriented only. So, whatever the data or whatever the processing that you're doing, it reads the data from the disk, it do the transformation, and it again loads the data to the disk. Again reads the data from the disk, again loads the data to the disk. So that is where whenever you're dealing with the disk, the processing will be very slower, but it follows that only. And one more thing is that it can only be used for the batch pipelines. You cannot create the streaming pipelines here. Okay, so this is what is MapReducer. MapReduce is one of the programming framework, I would say, in a simple terms. It is one of the programming framework to process a large amounts of the data. Okay, it is one of the programming framework to process a large amounts of the data. So that is the reason it is called as a processing layer. And it, with the help of the MapReduce, we can only use the Java to create. I mean, this processing framework, if you wanted to write, that is written in Java only. So if we wanted to use this one, we need to use the Java only. So we need to create all the pipelines with the help of the Java only, which is a very, very difficult language or a complex language. And if you wanted to create a complex pipelines, it even becomes more difficult to manage the pipelines. And one more thing is that it is a disk-oriented manner. So if you wanted to create a pipelines, oh sorry, whenever your pipeline is running, the data in between in the middle level steps, all the data is stored in the disk only. When you're dealing with the disk, the processing is very slower. And we can only create the batch pipelines, we cannot be able to create any other streaming pipelines. So that is what is Hadoop, guys. Map reduce. Okay, so that is how. So these are the main four things that the MapReduce is having. So MapReduce is one of the programming framework. All the data pipelines needs to be created with the Java only, and it is a disk-oriented manner. It can only be used for the batch pipelines. Okay, so this is how it is. And the next component that they have introduced is that Yarn. Sir, Yarn is like a cluster manager tool, cluster management tool. It is a cluster management tool. So what is a cluster management tool? A cluster management tool is like someone which manages the resources for your jobs. It's a manager for resources. Cluster management tool is like it manages the resources for your jobs. Sir, if you have some 10 jobs, 15 jobs, 16 jobs, 100 jobs, so the for each and every job there has to be a compute resources to be created, and those compute resources to be allocated for the each job. Then only the job can able to job will be able to perform and it will be completed. So if you wanted to, if the job has to run, the resources has to be allocated. Those resources will be created by the cluster management tool only. So all the jobs are allocated using the cluster management tool. So Yarn is one of the cluster management tool. There are many other cluster management tools are also available, but when the Hadoop was introduced, Yarn was one of the important tool. Even today, Yarn is also still used. So other than that, we have a Mesos and we have a Kubernetes also is there as a cluster management tools. Okay, so this is how Hadoop, sir. So this is what is Hadoop. Okay. So when the Hadoop was introduced, why Hadoop was introduced? Why Hadoop was introduced, guys? Can anyone tell me?
To store the data instead of files, we can able to store into data into Hadoop.
Okay, that's part of it. It is correct. Why Hadoop, guys? Sir,
to store
Hadoop.
the to store the huge amount of data.
Correct. So to work with the big data pipelines in a single word, sir, if you go 10 years before, you do not have any a single framework you do not have a single framework which works with the big data pipelines. If you very huge amount of data, 10 years before also is there, but at that point of time you do not have any tool which works with the big data. You cannot create a pipelines, you cannot be able to store it at all. So you have a very huge amount of data at that time, but you do not have any tool to store that also. So that's where the Hadoop came into the picture, and it was introduced with three main components. One is HDFS, MapReduce, and HDFS will store any amount of big data also. Very huge volumes of the data also it can able to store it, and it works with a map reduce. Sorry, the next one is a map reduce. The map reduce is a processing layer. The best thing about the processing layer is that it can be able to work with a huge amount of the data for the processing. It is a very extensive programming framework, but managing the creating the pipelines is difficult, but we can able to create it. It is a disk-oriented manner. It is a kind of a slow, and it can create only the batch pipelines. Now tell me, what is the drawbacks of this map reduce? HDFS is able to store any amount of data. There is no drawback. But can you guys tell me what is the problem with the map reduce? Can you guys tell me, by looking at it itself, you can able to easily tell what is the problem with the map reduce?
Streaming pipeline cannot be done.
Correct. Streaming pipelines cannot be done. That is one thing. Perfect. And next thing.
It is a disk oriented. That means
It is disk oriented. Perfect. That is disk oriented, sir. It is a very slow. Yes,
yes.
that is also one more point. And the next thing.
It depends on Java.
It depends on the Java only, but I do not know the Java, sir. All our data engineers are not knowing the Java. They are very good at Python. So again, so we do not know that. Okay, so this is how these are the challenges that we have. That so we do not know the Java, sir. Creating the pipelines with the Java is also very complex. Okay, sir. Do we have any other alternative for the map reduce? So, like 8 years before, people were looking for one more alternative for the Hadoop map reduce. We are not talking about the Hadoop, we are talking about the map reducer. Map reduce is one of the processing framework. So to do the data processing, we are facing a challenges like Java, disk-oriented manner, and batch pipelines only. So that's where Hadoop has introduced one more tool, that is anyone. Can anyone guess it?
Spark.
They have introduced Spark, guys. Okay, suppose Spark was introduced. Okay, so this is a one more tool. What is Spark? Can you guys tell me what is Spark?
To process the data.
It is also a processing layer. Okay, it is also a processing layer. It is also a programming framework similar to the MapReduce only. Okay, most of the concept for developing the Spark, most of the concepts for developing the Spark was taken from the MapReduce only. Okay, so MapReduce, most of the concepts from the MapReduce only they have taken and they have created the Spark. And now the advantage with the Spark is that it supports client libraries. It supports client libraries such as it supports Python, Java, R, Scala. Beautiful. So one of the problem is fixed. Sir, now with the help of the Python or Scala also I can able to create the Spark pipelines, which is a big data pipelines. Earlier, to do the data processing with the MapReduce, we were only using the Java, which was very complex. Now, the Spark supports Python, Java, and Scala. So with the help of these languages, we can able to create the pipelines and manage it easily, even though the complex requirement also can also be fulfilled with the Spark. And the next thing is that, sir, it is a in-memory. It supports in-memory computation. In-memory computation. So while it is doing the computation or while it is doing the data processing, the middle level steps are going to be performed using the memory only. So what do you mean by that? Let me gonna tell you guys first. So for example, what happens, a typical pipeline looks like this. Okay, you will be having a source, you will be having a destination, right? So take a two pipelines. You will be having a source, you will be having a destination. So what happens is that you read the data from the source, you create some data frame or RDD. You read this R data frame is actually stored in the disk. You again do some transformation one, you create a data frame 2, and this data frame 2 also stored in the disk. Again, you read the data frame 2 and you apply transformation on top of that data frame. Again, you are storing it to the data frame 3 in the disk only. Okay, So again, you read the data from the data frame 3, again from the disk only. So when you are reading it from the data frame 3, that means you are reading it from the disk only. You are doing the transformation. You are creating a data frame 4. Again, this data frame 4 is also stored in the disk. And you are writing the final data frame to the destination. Okay, why we are creating this many data frames is that to transform the data we may have to do the multiple transformations, right? To properly as per the requirement, if I wanted to get my shape my data, we need to do multiple transformations. So transformation 1 2 3 something like that. So you are writing it to the destination. So now tell me, all the middle level steps are stored under where, sir?
The disk.
In the disk only. So when you are dealing with the disk, so that is where the processing becomes slower. That is where the processing becomes a slower. So that is the reason this is a map reduce. How this is how the map reduce works. So that is the reason map reduce is slower. Okay, sir. Instead of a disk, can I go for memory? Instead of a disk, can we go for the memory? So that is
Yeah,
what
Spark.
earlier, if you go back maybe 5 6 or 10 years before, you have a smartphones also. At that point of time the storage was good, the RAM was like 2 GB 1 GB only, our mobile phones, if you remember. Okay, the RAM was 2 GB 1 GB only. But nowadays we are using a mobile phones of 8 GB RAM also. Why? Because when you are increasing the RAM, the processing speed will be very high. Okay, so when you take the same pipeline and if you remove here the disk, all the middle level operations are operated on the memory only, nothing but a RAM. Okay,
But
nothing but RAM.
one question, Rahul. So the more you save the data in the memory, okay, so it may lead to the performance issues again, right? I mean, we don't want to uh, store, unnecessary things or huge volume of data in the memory because it will again create the problems, right?
No, it doesn't do that like that. It doesn't work like that. And even though it is creating such kind of issues, we have to do some kind of a optimization techniques. So usually, what is that is so when you are doing a lot of jobs on a single cluster, that may happen. But the thing is that we will be having our job clusters.
Okay.
Okay, the job clusters will be having only one specific job will be running on that particular cluster, and once it is done, the cluster will be deleted. Okay, so when it is doing is that, so and again a cluster. So whatever we are doing here, it is everything with a cluster only. So you will be having a multiple machines in the cluster. So the data will be stored in a multiple machines. So that is the reason you will not be facing such kind of issues when you're dealing with the RAM and once the job is done, the data will be disallocated from the RAM. Okay, so the data will be removed from the RAM. So that's how it works. Okay. Yeah. So this is how your Spark works. So that is the reason Spark is called as a in memory. All the computation is done in the memory, in memory. So that is the reason it is called as a in memory. And it is called as a disk oriented manner. It is because all the steps are done in the disk only. So this is how you can able to see the difference. So it is a in-memory computation because all the middle level steps are going to be done. And one more thing is that the beautiful thing about the Spark is that you can also do the batch pipelines as well as you can also create streaming pipelines. Okay, you can also create streaming pipelines. So that is the best thing about the Spark. So this is how the Spark becomes very famous. Okay, the Spark becomes very famous. So this is the reason. This is the reason. Now the thing is that, sir, when the Hadoop wanted to do HDFS, MapReduce, and ARNA, these are the softwares, right? So these are the programming frameworks, and these are like tools you can think of. ARNA is a tool, MapReduce is a tool, HDFS is a tool. These are the tools. And if they wanted to use any of these computation, they need the infrastructure. Yes or no? So these are the tools. If the HDFS has to store a lot of data, it needs the infrastructure to store the data. So that infrastructure is nothing but a cluster. Okay, nothing but a cluster. Can anyone tell me what is meant by cluster?
Cluster is nothing but a uh, group of
Correct.
uh, group of servers or group of
Correct.
disks, something like that. Yes.
Correct.
In
It's a
databases,
collection.
we can in
It is a
databases we
collection.
can call it as group of databases.
Data in the order, in the sorted manner.
So no. Cluster is different. That cluster is different. So cluster in the Hadoop cluster, when I say, or a data pro cluster, when I say, it is a collection of machines. So you will be
Yes.
having the master machine, and you will be having the worker machine. Okay. So I would just say yum. You can also call it as a master node. Okay. A node or a machine, both are same. Okay, you
Master
will be
machine.
having a master machine, and you will be having a worker nodes or worker machines, worker 1, worker 2, and a typical cluster looks like this worker 3. So what happens here, let me try to tell you. Most of the people does not know this one yet. Let me try to give you some idea. Okay, so that you guys get it. So this is how a typical cluster looks like, guys. If you go and see it, what is a cluster, sir? Means a cluster is nothing but a collection of machines. Okay, let me try to explain it. Okay, so go down. Oh, okay, I'm gonna come here. Oh. Okay, let me remove it here, and let me try to explain it. So what happens, sir? I have some 100 GB of the data. So let us take a simple use case and try to understand it. Sir, I have a 100 GB of the data. 100 GB or TB. 100 GB is a very huge. In 10 years before, 100 GB of the data means it was very huge data. And they wanted to store it, and then they wanted to process it. So this is the challenge, right? So for storing the data, storing it in a 100 GB of the data in a single machine is not possible. Okay, it's not 100 GB. Let me make it as 100 TB. Let us make it as 100 TB so that you guys can easily interpret it, illustrate it. Now tell me, sir, I have 100 terabytes of the data, because that is what we call as a huge amounts of the data. So storing 100 terabytes of the data is possible in one single machine or not? Can we store the 100 terabytes of the data in a single machine or not, sir?
It's
Guys,
possible, but based on infra, how much RAM, how much storage.
so 100 terabytes of the storage is a very hard to store in a single machine. And managing that 100 terabytes of the data on a single machine is very difficult. Okay, there are plenty of challenges associated managing the 100 terabytes of the data on a single machine. So it is not possible. So if it is not possible it on a single machine, what is the other way, sir?
Create another machine.
So instead of storing the 100 GB of the data on 100 terabytes of data on a single machine, can we go for multiple machines so that we can able to store it? Multiple machines. Sir, if it is not possible in 100 terabytes of the data in a single machine, what I'll try to do is that I will take three machines. I will take three machines, machine 1, machine 2, machine 3. 100 terabytes of the data I take. And I split this data into the 33 here, 33 here, 33 here. So this is how we can easily manage it. We can easily store it. So this is a concept of distributed machines. Okay, this is a concept of distributed machines. So distributed machines is nothing but a few machines working together. So the few machines are working together to achieve something is nothing but a distributed machines are cluster. Distributed machines are collection of machines. So that distributed machines you call it as a cluster. That distributed machines you call it as a cluster. But who is actually splitting the data and distributing the data? Who is telling these machines to distribute the data and split the data first, and they have to distribute it, and how much amount of the data was actually stored here, how much amount of the data was actually stored here. So to track it, we need the tracker, and we need someone to manage this entire details. So that is our HDFS. That is our HDFS. So HDFS, what it will do? HDFS is a smart tool to split the data. It is having a mechanism of, it is an engine, or you can think of it like a software. It is a mechanism of where it splits the data and distributes the data to the multiple machines. Okay, so it needs a cluster of machines to store any amount of data. So it works with the cluster. Now the cluster, if I go, now the cluster, this is my cluster. And in my cluster, I have worker machine 1, worker machine 2, worker machine. These machines I am calling as worker machines. Why? Because these are the ones actually storing the data. So these are the ones actually doing some work. So that is the reason we call it as a worker machines. And how much amount of data they are actually storing and how they have stored it, and to track every detail that the worker machine is doing. So that is where the master machine is for. So master machine is for tracking the details of each and every worker and splitting the data to them and tracking the data, tracking their status, tracking their activity and everything. So that is there you have a master machine. So this is how our HDFS works. Okay, HDFS is a mechanism, it's a tool. It specifies to the cluster is that, okay, you have a machine. If you have a 4 machines, one of the machine has to be a master. All other things supposed to be a worker nodes. Master machines should be keeping the tracks of all the things. Worker machines are the ones doing the actual work. So this is how the HDFS will take. Okay, so if you wanted to understand it in a very simple way, take a project. You will be having some project requirement. In a project requirement, to fulfill the project requirement, we will be having a project manager. We will be having a multiple developers. Developer 1, developer 2, developer 3. This entire thing I am calling as a project. This project is running based on this requirement. So this requirement is our HDFS. And it will be, and this is our cluster. This is our cluster. A cluster is nothing but a collection of something. Now this is my project. As per the project requirement, this entire project is working. Okay, now this project manager, what he will do, sir? The project manager is he doing some development work? No. In the development work will be done by the developers. So that is a similar fashion to your master machine and all of these things. Okay, is that clear, guys? Anyone have any question here? The very simple thing is that you cannot be able to store a very huge amount of data. Today is 100 TB, tomorrow it is 1000 TB, day after tomorrow it is petabytes of the data we are going to talk about. It cannot be easily managed and stored in the single machine. In that case, we will be planning to, if it is not single machine, we go for multiple machines. So that's where the concept of distributed machines came into the picture. So using the distributed machines, HDFS stores a multiple any amount of data. With the help of the HDFS, we can able to store any amount of the data using the cluster. So cluster is nothing but a collection of machines where you will be having a master machine and worker machine. A machine is nothing but a node, sir. Some people call it as a node. It's just terminology, okay? It's just terminology. Machine is nothing but a node. So master node, worker nodes also you can call it as. Okay, so that is how, this is how HDFS stores data. Okay, so now the thing is that similarly, the processing also needs to be taken care. Processing also, this entire amount of a data, huge data, doing the data processing also very hard. So that's again, the processing will also be done with the help of this cluster only. So where you have already the data, on top of the data only, the code will move to this particular machine. The code, the processing code will go to this machine. The processing will be done here. The same code again goes to this machine. It will be done the processing here. So that is how the processing in the MapReduce is also, or in the Spark also works in the similar fashion with the cluster only. So worker machine stores the data, worker machine process the data. Okay, so this is how you can able to store any amount of data. Any data can be, any amount of data can also be processed here. So this is how the this is how your HDFS, MapReduce, and Spark works. Okay, so this is how, with the help of the cluster, they are going to store the data. With the help of the cluster, they are going to process the data. Now the problem is that we already know that managing the infrastructure is not easy, and managing this cluster is very hard, because it is not one machine, two machine. It is going to be sometimes a cluster is having some 10-15 machines also. Okay, for a very hard processing, there can be also 10-15 machines also. Now, who is managing this cluster? And managing the cluster is very hard. And do we have an alternative to manage the cluster?
We have some frameworks like Kubernetes, Docker, something like that.
Yes, but who manages the installing all of these softwares and making it available for all of these things?
Okay.
So the thing
Which is
is
the
that, so the thing is that creating the machines is not an easy. It's an easy task, right? So creating a one virtual machine is an easy task. But the thing is that making it connected together all the time, right? They have to working together only. So finding the developers is easy. Finding the developers for this particular requirement is difficult, and make them available all the time and working, they have to work together so that the project requirement will be finished. If they are working individually, they cannot be able to complete the requirement. So the same here, creating the virtual machines is easy, but creating the virtual machines and connecting together all the time is difficult. On top of this cluster, we need to have the HDFS installed, Spark installed, other libraries, a MapReduce, many other things needs to be installed. So it can be possible manually, but it is a time taking and effort taking and money taking. So instead of that, Google Cloud Platform comes up with a data proc. Okay, Google Cloud Platform comes up with a data proc. What kind of a tool it is? Tell me, sir, what kind of a tool it is?
Cluster based.
It is a managed cluster-based service. It's a fully managed cluster-based tool where it manages the cluster for you. You provide the configuration, it creates a cluster and manages the cluster for you. And on top of this cluster, it installs whatever the softwares you mentioned. It by default it installs the Spark, it installs the MapReduce, it installs the HDFS, it installs the Hive. Okay, all of these Hadoop tools, it is by default is installed. And the main purpose of the data proc is to run the Spark and Hadoop jobs only. Okay, so this is how. Similarly, if you go outside, you can also find Amazon Glue, which is also similar to the data proc. Amazon Glue. If you go to that, you have a data bricks also, so which is similar to the data proc. So this is how you have a different tools, which the main purpose of these tools also the same thing. They are managing the cluster and all the softwares are installed. The main purpose of these tools also to work with the Spark and Hadoop jobs only. Okay, so this is how the data proc is for. Now you got to know the understanding that the why Hadoop, why MapReduce, why HDFS, why R, and why MapReduce, why not MapReduce. Now why Spark, why not MapReduce also you got to know. Now you got to know that why data proc. So this is what is a data proc. Yes, any questions, anyone? Do we have any questions, guys?
Can you give me the examples of stream pipeline and other alternate pipeline, right? What is the difference?
There are plenty of things, right? So streaming pipeline is something, or a batch pipeline is something like this. So for example, sir, I have a, so that try to understand what is batch, what is stream. Sir, batch is of a fixed size data which is of fixed size, right? The data will not change for the batch. Streaming, it is a continuous data. That means the data of unlimited size. We do not know the size of it. The data is keep on coming. So that's the reason we call it as unlimited size. So continuously data coming in. Only a fixed data is coming in. So to work with that, we are going to create a pipeline. So batch pipelines, we call it as Streaming pipelines we call it as. For example, so assume that I have a Google Cloud storage. Inside that I have a CSV file, a CSV file of 1 GB. So when I say a CSV file of 1 GB, it is a fixed size. It does not change it, right? So you write, you load the data, you extract the data, you transform the data, and you load the data to the multiple tools. Okay, maybe for the BigQuery you are going to write it to BigQuery table. Okay, so for transforming and extracting all of those things, you can use Dataproc for that. Okay, so this is one use case. This is one typical pipeline. Okay, where you have a CSV file or a JSON file or a Avro file, whatever it is, so which is a fixed size. And similarly, on the other hand, data continuously coming in. So when I was recently working, the recent project, the recent POC project that I have worked for Mahindra and Mahindra as a POC, we all know that Mahindra XUV 700, right? So which is very famous nowadays for the 7-seater car. So for this car, I have worked for battery leakage problem. So what is the problem here is that, let me gonna tell you, it's a very interesting use case. So for this one, so for the battery, it produces the data. Okay, with the help of the radars and with the help of some, whenever you create a one, whenever you are trying to call someone, right? So there will be some data is generated. Similarly, whenever the battery is actually working, it generates some kind of a data. So that data is actually storing it in the streaming data tool, maybe PubSub. Okay, so whatever the data, there is a PubSub topic is there, or a Kafka, whatever it is, PubSub topic is there. This entire data, batteries data, will go to the PubSub topic. Okay, PubSub topic is actually a topic where it stores the data from the battery. Okay, now this data is continuously coming in because it is a data coming in streaming manner. So that it is a streaming data. So it is continuously coming in. So it is of an unlimited size. Now we need to extract this data sometimes, transform this data, and load the data to the BigQuery. Now, what is our agenda, sir? Why we need to extract it and transform it, load it? So the data that you're getting it from the battery may not be usable for the directly analyzing purpose. The main agenda is that, so you have a battery and that battery produces some data, and that data needs to be stored properly. And if I wanted to find the leakage, so they have a parameter that is DL, nothing but a data leakage or a fuel leakage, DLF limit is there. If the DLF limit is more than 20, there is a leakage happening. There is a chances of leakage. So that is what they say. Okay, for this particular XUV 700 battery, the leakage limit is DLF 20. If the DLF parameter is more than 20, then there is a leakage happens. Now, we need to, whatever the data that I am getting it from the battery, we need to transform it data so that I get to this one of the parameters, that is one of the column, that is DLF. And if I have to write a where condition, I have to filter it out the data. Not is actually the where condition. It was, we have used the PySpark actually. We have to filter this data. Okay, we have to filter this data. And if it is more than 20, we need to send this data to the BigQuery. And for all the BigQuery table, whenever the data is inserted, all the customers has to be intimated that there are chances of battery leakage for your car. For all the customers, we have to intimate it. So this is one of the beautiful use case that we have done. And here we have created we have used the data bricks for this one. Data bricks for this one, which is similar to the data block only. So where we have created a delta live tables. So what it will do is that it reads the data from this topic, because the data is directly streamed to the topic. From the topic, we have to read the data and we have to extract it, transform it. First, to transform it, we need to transform it to the proper format, convert it into the columns. Once the column, we found that the filter, and we need to find more than 20. And we need to create a load this data to the BigQuery, or we need to load the data to the some other tools. So that is how now whenever the table data is more than one record, the customers has to be intimated properly. Okay, so this is how one of the battery. So this is one of the streaming use case. So batch use case, the fixed size you are going to deal with. So streaming use case is that you do not know, for when the battery is very new, you may not be able to see the problems. That's the reason your customers are happy with that. But after few days, there can be a battery leakage, but this pipeline is, once it is created, it is keep on continuously running back end, even for years or months also. Once the this particular pipeline is running, at some point of time, maybe after few years, it will get to know that uh, this particular battery is getting leakage because of the DLF level is more than 20. So that is how your streaming pipeline works. It is continuously running. But this batch pipeline it is one-time activity. Once this entire data is done, the data will be moved to the BigQuery. The pipeline will be stopped because it is a one-time pipeline. Batch pipelines are one-time. Okay, streaming pipelines are continuous pipelines. Okay, so this is how it works, guys, for the batch and streaming. Any
So
question?
one question. So you were mentioning that PubSub topic, right? Is it a Kafka topic or other
Similar
topic?
to the Kafka. In Google Cloud Platform, we have a PubSub. Okay, so which is similar
Okay.
to the Kafka. Both are same. In Kafka, you call it as a producer consumer.
Yeah, producer yes.
Here, you call it as a top publisher and subscriber. Pub means
Okay.
publisher, sub means subscriber.
Okay.
Yeah.
Sir, this Dataproc and these services, it will handle unstructured data also, or only for the structured data purpose?
It works for semi-structured data. Yes, semi-structured data. Sir, I have a CSV file which is a semi-structured, JSON semi-structured, right? So all of these files you can able to deal with that data, and you can able to convert it into the tables and load it to the some other tool. Okay.
Okay.
Yeah. Even this data is logs, which is a logs is a unstructured data only, right?
Unstructured, yeah.
Yeah. So you are getting the data in the form of a log only. So you are going to transform it, and that's how you are going to send it. So your data source can be structured, semi-structured, or unstructured. But finally, you are going to make it to the structured so that you can able to easily understand it, and you can able to easily process it, so that analysis will be easier. So when you get the analysis, you get some kind of insight. This is what is insight, sir. When I am saying insight, what is insight, sir? People may be asking. The insight is that whenever whenever the tabular data is this day, the record is added. That means there is a leakage. There are chances of the leakage. Now the customers will get to know that. Okay, for all the people, there will be a BigQuery table will be there, and from that table, there will be email will go to them. So they will try to create some kind of a email kind of a service using the PubSub only. They will do that. Okay, again PubSub Cloud Functions. And when the customers get to know that there is a battery leakage, they will go to the service center and they try to replace the battery. So that is how the insight will help the customers to take a proper decision, right? So this is how the insights are very useful. So if you don't process the data, if you don't process it and analyze the data, you don't get this kind of a insights are very useful, guys. Okay. Yeah.
And what is the code we need to write, sir? Which language of code?
So
Like
this code was written in PySpark.
Okay.
Most of the times the code will be writing, we are going to create the code in the PySpark only. In the BigQuery, if you wanted to write, you can write it in the SQL query also, because there are plenty of the table, plenty of customers will be there. I wanted to filter out the customers only for one customer. You can use SQL in the BigQuery, but in the Databricks we have to use SQL or PySpark also. We can do it, but PySpark is more manageable because it has a plenty of libraries. We can able to do any type of processing also, transformations also. Okay.
Okay. Thank
So
you.
this is how it is, guys. So now let us do one thing, and the final thing is that, sir, how to create the cluster. Let me gonna tell you how to create the cluster, and we will wind up the session. Or maybe we will see it tomorrow, guys. It's already 27. We will see it tomorrow. Okay. So hope you got some idea about what is Dataproc, and what is Hadoop, what is Spark, and what is MapReduce, and how the batch and streaming pipelines looks like. Okay.
Sir, one question, like
Yes.
how we can decide data proc or data lake, data flow?
So it depends on the requirement, right? So, sir, my developers are more of a Spark based. Okay. And sir, the requirement is that the client is asking for the Spark touch only. In that case, you have to go to the data proc only. You do not have any other chance, right? Okay, sir, my client is asking for the Spark pipelines. So if he is asking for the Spark pipelines, you can't go for the data flow because data flow is not having the Spark touch. Okay, it is a beam pipelines. So it's based on the requirement. And one sometimes it is also the developer's choice. Sometimes, sir, I wanted to do the data processing. My developers are only know the PySpark. They does not know the data flow. In that case, going with the PySpark will eventually not lead to the extra training required for them, right? So they can directly work on the PySpark only. So that's again depends on two things. Most of the times it's the customer requirements, sir. Client requirement only. Okay.
Why I asked, right? The Mahindra battery case,
Correct.
right? You used their data lake.
No, we didn't use their data. Data lake is something to store the data. Okay. It's not about data lake is not for the processing. Data lake is to store the data. You can store anywhere. Okay, storing the data is anywhere. You can store it in the GCS only. Actually, that data was actually stored in the data lake. Data lake is nothing but again GCS. GCS is nothing but a data lake, sir. If I tell you or not, a data lake is a location where we store any amount of data, any number of files, any format. So that is one of the example for the data lake is like S3 buckets, Azure Blob Storage, and GCS. GCS is one of the data lake. Okay. And for the processing, you can use PySpark or you can use Beam or you can use SQL or you can use any other language, for instance. Okay. Yeah. Okay, guys. I think
Sir, these notes can be uploaded in the portal anywhere. The
I
images.
have shared you the link, guys. If I have shared you the link, if you guys remember yesterday in the chat, I have shared you the link. Go to that link. You have the notes. Okay. So these notes, I think I'll upload these notes also. So I have created one more notebook. I have given you the link for my notebook. So you'll be able to access these notes. And today we have seen one more thing also, right? Data proc. I will also put that data proc notes also here. Okay.
Can you please share one more time? I missed that.
Okay.
So BigQuery, whatever you have explained that much, sir, do we have any advance in
There
that?
are many other things. Okay. There are many other things.
So
There are
you are going to be explain in advanced.
advanced course. So you have a partitions and clustering, storage optimization techniques, nested and repeated fields, views, case studies, case study one, case study two. This comes actually in the advanced course. It takes actually BigQuery itself, it takes like 6 days, 6 to 7 days. Yeah, 1 week.
Okay.
Yeah.
Okay.
Okay, guys. Yeah. Thank you all. Have a great day. I have one more class to go, and we will see you tomorrow at the same time, guys. Thank you all. Have a great day. Bye bye.